So this video is on similar triangles and applying the angle-angle postulate to identify similar triangles and identify missing side lengths. So the examples that we're going to do are going to involve both identifying the similar triangles and then finding the missing side lengths by finding scale factors and then setting up ratios and proportions. So this is our first example. We have triangles QRS and UTS. I know angles Q and U, we're given Q and U are congruent to each other, so we want to figure out, well, what other angles do we know are congruent so we can apply the angle-angle postulate. Well, we know we've got vertical angles here, so we can mark off these angles as congruent to each other. Okay? So I can say that triangle QRS is similar to, if I go from Q to R to S, I'm going to go UTS. So those are my similar triangles, and I'm going to use this setup to identify my scale factor. So let's figure out what corresponding sides do I have in common. So our corresponding sides, we have QS corresponds to US. So our ratio, you can set up US to QS. So that's 4/16, simplifying to 1/4. This is going to be the scale factor that we're going to use to solve for x and solve for y. So let's solve for x first. So my scale factor is 1/4. Okay. I'm just going to set up the ratio over here using the side lengths. So x is st. Okay. So last two, and st corresponds to rs, last two. So I'll have x over 12, cross multiply, and then x is going to be 3. And the same thing with y. I'll use the scale factor 1/4. Y is side QR, so the first two corresponding to the first two UT. So I'm doing small over large, so I'll have UT over QR. So UT is 2 over QR, which is Y, cross multiply, and Y is going to be 8. Alright, so changing the figure around a little bit. So I have two overlapping triangles. I have parallel lines. So I know that I have corresponding angles here and here because I have my parallel lines, BD and AE. So I can start by marking off my corresponding angles as congruent. So I have enough information to use my angle-angle postulate just from this, but I also know they share angle C, so I can mark off C as congruent to itself. Okay? So my similar triangles, if I start with my smaller triangle, BCD, is going to be similar to, well, B is congruent to A, so go from A to C to E. So I'll use this ratio, or this relationship, to help me figure out what my corresponding sides are. So for my scale factor, I notice that BD corresponds to AE. So I'll set up BD to AE. So that'll give me 6 to 10. Which will give me 3/5 as my scale factor. Okay. So now let's use that scale factor 3/5 to solve for x and solve for y. Okay. So I want to solve for y first, and let's add in a left out. That should be 5, so let's add in 5 there. So let's use the ratio 3/5. And y is CD. So it's this segment, and CD corresponds to CE, this entire segment. This entire segment CE. So CD here, at length Y, corresponds to this entire segment CE. So that's the relationship we're going to set up. CD to CE. So CD is Y, CE, this entire segment. We have Y and we have 5, so this is going to be Y plus 5. Okay. So then cross multiplying this, I get 5Y. And then I'm going to distribute, multiply 3 times y and 3 times 5, so I'll get 3y plus 15. Then subtract 3y from both sides, so I'll get 15 equals 2y, and y equals 7.5. Okay. So we solve for y, now let's solve for x. And to make this a little bit more reasonable, I want to change this value of 2. So let's change that from a 2 to an 8. Okay, so I'll make my problem a little bit more reasonable. So again, we're working with the ratio 3/5. Okay, now I want to solve for x, but x is this segment. It's not the length of an entire triangle. So I want to relate it to this entire side, CA. Okay. So CA is this segment. I'll highlight it like this. So CA is this segment. Okay. Well, CA or AC corresponds to BC, which is this segment. Okay. And since I'm doing small over large, my ratio is going to then be BC to AC. So I'm setting up this BC, so this segment, over its corresponding segment AC, this entire length. So my ratio is going to start with 8 in the numerator, that's BC, so that's this length, over the entire length of AC. And just like we found the length of CE here, this is going to be, so I have 8 and x. So this is going to be 8 plus x. So this should be 8 plus x. Okay. So once we have this set up, let's cross multiply. Of 8 times 5 gives me 40. And then I'll distribute 3 times 8 gives me 24. Plus 3 times x gives me 3x. Subtract 24 from both sides, so I get 3x equals 16. Divide both sides by 3, and I'll get x equals 5.3. Right, in this next example, we've got, again, 2 overlapping triangles. We have right angles here and here, so we have one set of congruent angles. You'll notice that they share angle N. So that's our second pair of congruent angles, so we mark angle N as congruent to itself. So our similar triangles are going to be, again, if I start with a smaller triangle, if I go from M to N to O, similar to L, N, P for my larger triangle. Now my corresponding sides, MN, so my side length of 9, corresponds to LN, that entire side, which is 12. So I'm going to set up that as my scale factor. So I have mn over ln. So I'll have 9 over 12, and I'll get 3/4 as my scale factor. So let's use that to solve for x first. So x is MO, so it's the first and last side. So MO corresponds to LP, first and last. So I have MO to LP. So MO is X, LP is 6. So when I cross multiply this, I'll get 4x equals 18. Then x equals 4.5. Take a second, pause the video, set up your proportion, and solve for y. Look back on the previous example for help. Alright, so to solve for y, we're going to use the same scale factor, 3/4. So y is ON. So it's this, the last two letters. So ON corresponds to NP. So ON over NP. So ON is here. NP is that entire segment. So ON is Y. NP is this entire length. I have 2 and Y, so this is going to be Y plus 2. Okay. Now let's cross multiply. So Y times 4 gives me 4Y. 3 times Y plus 2, so I'll distribute the 3. So I'll have 3Y plus 6. Subtract 3y from both sides, and I'll get y equals 6. So your answers for this one, x should be 4.5 and y is 6. Alright, so for this example, I have a pair of parallel sides, so I know that on my parallel sides, my alternate interior angles are congruent, so angle Q and angle T are congruent, angle R and angle U are congruent, and I have vertical angles here, and I know they're congruent as well, but I have enough information just using angle to say that my triangles are similar. So I'll start with my smaller triangle, QRS. So if I go from Q to R to S, I'm going to start with angle T, because Q and T are congruent to each other. So I'm going to go from from T to U to S. And now to identify my scale factor, QS and TS are our corresponding sides. So I'll set up QS to TS. So that's 4/9. And I can't reduce 4/9, so my scale factor will say 4 over 9. Okay. Now let's solve for x. So I have 4/9. X is RS, so the last two sides, and RS corresponds to SU. So RS to SU. So that'll be my second ratio, RS over SU or US. So RS is X, US is 8. So I'll get 9x equals 32. And x equals 3.5. Now when I solve for y, I'll use the same scale factor, 4/9. Y is UT, So the first two here, UT, corresponds to QR. Again, I'm setting up small over large, so I'll do QR over TU. So QR is 5, TU is Y. So I'll cross multiply. And 4y equals 45, and y equals 11.25.